In this video, we will learn about quotient rule. So in the previous video, we learned about quotient rule. And now we'll learn about what is quotient rule and how to apply it to differentiate composite functions. So let's first write the rule, the quotient rule for differentiation. This is applied in situations where your functions is like something like y is equal to sine x over e to the power x. So y is written as a function divided by another function of x. One function of x divided by another function of x. So this is like fx is one function of x and gx is another function of x. Maybe I can give this another name. I'll write this as hx. So this is hx over gx, which we can traditionally rewrite it as u over v. So in product rule, if you recall, in product rule, the function y is written as the product of two functions, like sine x multiplied with e to the power x. So sine x is one function, e power x is another function, which we write as u times v. But in quotient rule, the function is written as a function divided by another function in x. So quotient rule says that dy dx or y prime or f prime x. So fx, y is fx, which is sine x over e to the power x. So f prime x, which is dy dx or y prime, is written as, can be differentiated using this formula, u prime v. So differentiate the function u, keep v as it is, minus v prime u, differentiate the function v and keep u as it is, over v squared. Remember, this v squared over here is just the v. There's no derivative over here. So the numerator is u prime v. U prime is same as du dx. You differentiate the function in the numerator, multiply it with the function in the denominator, which is v, minus v prime. That means you differentiate the function in the denominator with respect to x, this also with respect to x, and you keep the numerator function as it is, over v squared. So let's apply this in the question given. Say fx is sine x over e to the power x. So this is my function u, and e power x is my function v. If u is sine x, then what is u prime? U prime is cos x. And if v is e to the power x, then v prime is e to the power x also. Now we have u prime and v prime. All we need to do is put this in the formula in correct place. So f prime x will be u prime, which is cos x, u prime v, minus v prime. If e to the v is e power x, v prime is also e to the power x, v prime u, divide by v squared. So e to the power x squared, which is basically e power 2x. I'm just going to tidy this up whole thing. E power x multiplied with cos x minus e to the power x multiplied with sine x over e to the power x. If it is e power x squared, is basically e power x multiplied with e power x. In the numerator, we can factorize out e power x. So I'll get e power x multiplied with cos x minus sine x. divide with e to the power x times e to the power x. 1 gets cancelled out, and our final answer is cos x minus sin x over e to the power x. Let's take one more example of quotient rule. So I'll give you a slightly challenging function now. Say y is equal to y is a function of x and y is equal to square root of x plus 2 square over x. So we have y as a function divided by another function. I will take the numerator as u, take the denominator as v. So in u itself, we now need to apply chain rule. If u is square root of x plus 2 squared, there are two ways you can do this. One is apply the chain rule. So let square root of x plus 2 be z. So my function z is square root of x plus u. That means I can write u is equal to z square. Let's differentiate u with respect to z. Du dz will be 2z. And let's differentiate z with respect to x. So dz dx is equal to half x to the power negative half plus 0. Derivative of the constant 2 will be 0. Always derivative of constant is 0. So dz dx is equal to 1 over 2 x to the power half, which is root x. Now, so what will be du dz? Because what I need is actually u prime. And u prime means it is du dx. So I have du dz and I have dz dx. So du dx would be the product of these two functions. 2 times z multiplied with 1 over 2 root x. 2 and 2 cancels out. So we have z over root x. Z is root x plus 2 squared and root x. So this is du dx. My function v is x, so v prime will just be 1. Now let's put v prime and u prime in the formula. Y prime will be equal to u prime v minus v prime u over v squared. U prime is root x plus 2 square multiplied over root x multiplied with v, and v is just the function x, minus v prime, which is 1, multiplied with u, and u is root x plus 2 squared. Over everything is now divided with v squared. V is x, so v squared will be x squared. So let's simplify. Root x will cancel out and we get over here root x. So my numerator is root x multiplied with root x plus 2 square minus root x plus 2 squared. It's a slight error. This is z and z is just root x plus 2. So I should take away the square here. Over x squared. This is my dy dx or y prime. If you want, we can further simplify this by factorizing root x plus 2 from numerator. Let's do that. So if I factorize root x plus 2 from the numerator, I am left with root x minus root x plus 2 over x squared. Root x and minus root x will cancel out. So I have root x plus 2 multiplied with negative 2 over x squared, which is minus 2 root x plus 2 over x squared.